down is I have written down the steps that you would use if you're graphing a quadratic function using this method. Now, the three methods that we looked at, so factorizing, completing the square, and also using the quadratic equation, all of these three methods, you can use the different steps in the steps in each one of them depending on what you need. So for example, in the first one, when we were factorizing, some quadratics are quite easily, if you look at it, you'll be like, oh, I can easily factorize that. You might just go factorizing and then doing those steps in that case. There's some that are like, okay, maybe it's easier if I use a quadratic equation to find the roots and check the discriminant and see what happens. And there's some cases where you will have a look at, you'll use completing the square to find the vertex. Sometimes the question will always also tell you which one you need to do. So you just need to be careful. Maybe it's up to you to choose which one would work best for the question that you have. But let me just go through the steps that you need to do if you're graphing using quadratic equation. So the steps here, the first two hopefully are very familiar with you guys. You're really familiar with. The first one is you check the concavity. A is equal to whatever, and then you check, is it greater than 0 or is it less than 0? So you're checking the coefficient of the x squared term, and then you're seeing if it's positive or negative, and that'll tell you if it's concave up or concave down. You've done this step before. The next step is then you check for the y-intercept. So you sub x is equal to 0, or you check that y is just equal to c if your quadratic is in that form, ax squared plus bx plus c. Okay, now this is where it's a little bit different to the previous ones. Now, the next step is then you just find the axis of symmetry. Using our quadratic equation, we know that the axis of symmetry is x is equal to negative b over 2a. And so what you can do is just sub in those values. So identify what those a, b, and c values are. Sub it into your Sub it into your this axis of symmetry equation. Then once we've done that, we need to find the vertex. So then what do we do to find the vertex? Well, you sub the axis of symmetry to find the y coordinate. And once you've subbed the y, once you've got that y coordinate, then you have the coordinates of the vertex. So that's the tip of your parabola. Okay, then the next step, this is where it's a little bit different as well. So then you check the discriminant. So this is telling you how many roots are there. You check how many roots your parabola has. Does it have 2 roots, 1 root, or 0 roots? And so you check whether or not discriminant is greater than 0, equal to 0, or less than 0. Then, if the condition, if the condition is greater than 0 or equal to 0, then you find the x-intercepts. Because if the discriminant is less than 0, it has no x-intercepts. So here the x-intercepts is just a following step. So you apply the quadratic equation. So you just use the quadratic equation to find the x-intercepts where possible. What I'm going to do is I'm going to go through 2 examples with you guys here. Okay, so let's have a look at this first one. We're going to graph the following quadratic function. So we've got y is equal to negative x squared plus 6x plus 1. I'm going to go through this quite a little bit quicker than I would usually, but let's have a go through this. So first thing is we check concavity. Here, what do? We look at the coefficient of the x squared term. I'm just going to write a is equal to negative 1, which is less than 0. So we're going to have concave down. So we know our graph is going to look like an upside down parabola. Okay. Step 2. I'm going to check the y-intercept. The y-intercept is you sub in 0, or you can just check the c term, the constant term. Here it's already nicely in that form, so I can just go y is equal to 1 for the y-intercept. Okay, first 2 parts down, pretty nice and simple. Step 3 is where we get a little bit trickier. This is where we have to apply the stuff that we did with our quadratic equation. I'm going to find the axis of symmetry. All I'm going to do is now I should have done this before, but let's identify what my a, b, and c values are. So my a value, if you have a look at my quadratic, a is going to equal to negative 1. We already identified that in the first step. B is just a coefficient of the x term, which is just equal to 6. So I'm going to highlight them as I go. So I had negative 1, I had the 6. And then C is as my third step where I found the y-intercept. C is equal to just this positive 1. So 1. So my axis of symmetry, let me find that. So you remember the equation for my axis of symmetry is x is equal to negative b over 2a. And so I sub in my b and my a values. So I've got b is equal to 6, a is equal to minus 1. So I'm going to have negative 6 over 2 times minus 1. That will give me negative 6 over negative 2, which will just give me, when I simplify this and evaluate it all together, the axis of symmetry is equal to 3. Okay. Once I've found the axis of symmetry, what I need to find is my vertex. So I'm going to sub x is equal to 3 into y is equal to negative x squared plus 6x plus 1. So axis of symmetry, we just sub in your a, b, and c values, a and b values into this equation over here. This is your axis of symmetry formula. And then you sub in the axis of symmetry that you found, so x is equal to 3, back into the equation to find the vertex. So here I'm going to have y is equal to negative 3 squared plus 6 times 3 plus 1. So I have negative 9 plus 18 plus 1. I think this ends up giving us 11. So our vertex is going to be, the x coordinate is just the axis of symmetry, so 3, and the y coordinate is this 11 that we found. So the third step is your axis of symmetry. We figure out, we sub in our a and b values into your axis of symmetry equation, and then you sub that back into the value that you get from that back into your equation for the quadratic function. Okay. Final part. So section 4 is we check the discriminant. So 4, I'm going to check the discriminant. Now the discriminant, and I'm going to write underneath, I'll do it in black. Discriminant is equal to b squared minus 4ac. I'm going to look back up. My b value is 6, my a value is minus 1, and my c value is 1. So all I do is I substitute this into my equation. So I've got into this discriminant equation. So I've got 6 squared minus 4 times minus 1 times 1. That's 36 plus 4. Because I've got 6 squared, and I've got 4 times minus 1, which will make it positive 4 times 1, which is just stays positive 4. So it gives me 40. Now here's where I check. Is this 40 greater than 0, equal to 0, or less than 0? I'm hoping by now in year 11 you can all tell that 40 is greater than 0, which means that I have, so if you remember those conditions, I have 2 real roots. And so once I've done that, I can use my quadratic equation. Oh, and I'll actually just write here, just so we have it. Discriminant. We're going to check the discriminant. Once I've got this, all I need to do is then I go, okay, I can chuck all of my information, my a, b, and c, into my quadratic equation to help me find my roots. So here I'm going to have x is equal to negative b plus or minus square root b squared minus 4ac over 2a. Now sometimes in the textbook or also in questions they might just shorthand this and say write a big delta here, because that is the equation for our discriminant. I'm just replacing that. And also another thing is, because we already found the discriminant here, I don't actually need to do that substitution again. So here let's have a go through that. So I will have negative 6 plus or minus square root, we found that the discriminant was equal to 40 over 2 times minus 1. Now, if you remember your work from surds, we can actually simplify this square root 40. Square root 40 is just, I can take out a perfect square factor of 4. 4 is a perfect square. I can take that out, and so it becomes, the square root of 4 is 2 square root 10. That's what's left over. So here I'm going to have negative 6 plus or minus 2 square root 10. 2 square root 10 over negative 2. And so when I simplify this, this gets me 3 plus or minus square root 10. So that minus 2, I'm cancelling that from the top and the bottom, so I'm left with 3 and 1. Now, because that minus sign would have changed that plus or minus, because we're doing both plus and minus separately anyway, it doesn't matter which order it becomes. It doesn't really change it too much. So here I've got my 2 roots are 3 plus or minus square root 10. And so if I put that in my calculator, this actually gets me roughly, so this is roughly negative, so when I do 3 minus square root 10, I get roughly negative 0.16. And when I add it, I get roughly 6.1. 6.16. Okay, cool. So that tells me where the two x-intercepts are. So I've done all these 4 steps. So I checked the concavity and the y-intercept, which were always my first 2 steps. Then I checked the axis of symmetry, where I found that the axis of symmetry was at 3. So I substituted those a, b, and c values into my axis of symmetry equation. And then I substituted that value that I got over here. So I'm going to highlight this. So I've substituted this value that I got over here back into my quadratic function, so I could get the vertex, bottom here. Once I've done that, then I check the discriminant. So I use this equation over here, b squared minus 4ac. I check what it's whether or not what its condition relative to 0 is. Is it greater? Is it equal? Is it less than? And then I found that it had 2 real roots. So then I found what those roots are. So I had the roots over here by using the quadratic equation. Now, let's actually draw all of this onto a graph. So the first thing I know is a concave down graph. I know that the y-intercept is at 1. I know the vertex is at x is equal to 3. And I know it has 2 roots at negative 0.16 and 6.16. So I'll just actually circle these as I go. So as I look through this, I've got that, I've got this, and I've got these 2 values. Okay. So if I was graphing this, I'm just going to go, okay, cool. I've got my axis of Cartesian plane, y, x. And I know that there's a x-intercept to the left of the y-axis, so this negative 0.16, and I've got one over at 6. I've got the vertex at 3, so directly in between, and y-intercept 1. So what it's going to look like is something like this. So there's a x-intercept somewhere a little bit less than 0. Y-intercept at, I'm just going to redo this, it's a little bit squiggly, I'm so sorry. Got x-intercept somewhere less than 0, just a little bit. I've got an y-intercept of 1. We've got a vertex at 3, 11. Got another x-intercept at somewhere around 6. So let me just label on all the information here. So let me start from the left. So this one is your x-intercept, which was at negative 0.16. So this was 3 minus square root 10. I've got a y-intercept at 1. I've got a vertex at 311, I believe. So this is 311. And I finally got a another x-intercept at 3 plus square root 10. And so this is my quadratic. Y is equal to negative x squared plus 6x plus 1, I believe. Okay, cool. So this is me combining all of that information, putting it together into one graph here. So this is how we use the quadratic equation to graph a quadratic function. I'm going to go through another example with you guys. So this is the other